In this video, we will discuss Chapter 3, Sections 3.7 through 3.10. You will need to watch the video for Section 3.7 in your online textbook before viewing this video. You will recall from the video note on Section 3.7 that we can use math.random to obtain a random double value between 0.0 and 1.0, not including 1.0. We will consider the problem of developing a program for a first grader to practice subtraction. We want our program to randomly generate two single-digit integers that we will call number 1 and number 2 and display a question to the student. The student will then enter the answer and the program will inform the student if the answer is correct. Previously, we used system.currentTimeMillis to generate random numbers. We'll now leave that behind and use the math.random method moving forward. As you learned in the video notes, math.random is what we use to generate random numbers moving forward. Remember, when we use math.random, we get a random double between 0.0 and 1.0, excluding 1.0. If we want to generate a random integer, we will need to use casting. Recall from your textbook resources listing 3.3, in order to swap the value of two variables, we need to introduce a temporary variable. Consider the example on the slide. We want to swap the value of number 1 with the value of number 2. To do so, we first introduce a temporary value we call temp, and we store the value of number 1 into temp. Next, we store the value of number 2 into number 1, and finally, we replace number 2 with the value that's currently in temp. It's important to remember that in order to successfully swap two variables, you must always introduce a temporary variable. We will now consider the case study Computing Taxes in Section 3.9. In this case study, we will use nested if statements to write a program for computing federal taxes. Consider the table that shows the tax rates for 2009. Tax rates are calculated based on the filing status and income. There are 4 filing statuses: single, married filing jointly, married filing separately, and head of household. In order to write a program to compute personal income taxes, we must prompt the user for several pieces of information. First, we must request their filing status. We will ask them to enter a 0 for single, 1 for married filing jointly or qualified widow, 2 for married filing separately, and 3 for head of household. Secondly, we must ask for their taxable income. Consider the pseudocode on the right side of the slide. We will use a multi-way if-else statement to check the filing status. Within the multi-way if-else, we will nest an if-else statement that checks the income level and computes the tax accordingly. Please refer to listing 3.5 in your textbook in section 3.9 for the full code. Additionally, you will need to watch the video note for this section for a step-by-step demonstration of the program development. Pay special attention to the introduction of the exit statement, system.exit, open paren 1, close paren, on line 53. This is the method that we call to terminate the program when we have invalid input. In this case, if the user enters a filing status other than 0, 1, 2, or 3. Additionally, review the code on line 57 that displays the tax as a decimal value with at most 2 decimal places. The logical operators can be used to create compound Boolean expressions. The 4 logical operators are shown in the chart. The exclamation point used for not or logical negation, the double ampersand sign used for and or logical conjunction, the double bar, used for or logical disjunction, and the caret, used for exclusive or logical exclusion. We will now consider the truth tables for each of these operators. Logical negation serves as a toggle to change the value of an expression. It is a unary operator, which means it requires only one operand. If an expression evaluates to true, then the logical negation of that expression, achieved by putting an exclamation point in front of the expression, changes its value to false, and vice versa. Logical conjunction, achieved by the double ampersand sign, is a binary operator, which means it requires two operands. Each operand is a Boolean expression that evaluates to a Boolean value. The resulting compound Boolean expression only evaluates to true when both of the operands have a value of true. In all other cases, the expression formed using the double ampersand sign will evaluate to false. Logical disjunction, achieved by the double bar, is a binary operator, which means it requires two operands. Each operand is a Boolean expression that evaluates to a Boolean value. The resulting compound Boolean expression only evaluates to false when both of the operands have a value of false. In all other cases, the expression formed using the double bar will evaluate to true. Logical exclusion, achieved by the caret, is a binary operator, which means it requires two operands. Each operand is a Boolean expression that evaluates to a Boolean value. The resulting compound Boolean expression only evaluates to true when exactly one, that is one and only one, of the operands has a value of true. In all other cases, the expression formed using the caret will evaluate to false. Please refer to listing 3.6 in your textbook for an example program using the logical operators. This program will check if a number is divisible by 2 and 3 using the double ampersand sign, by 2 or 3 using the double bar, and by 2 or 3 but not both using the caret. As our Boolean expressions increase in complexity, we can use De Morgan's law to simplify. The application of De Morgan's law is beyond the scope of this class, but it's mentioned for completeness and for the benefit of the curious student.